So that's this first thing for today. How you set out a problem to find the surface area or the volume of something. So in addition on this question, as well as determining the mass of the hemispherical copper container, I also want to find the surface area. I might decide once I've made this thing I want to spray it to protect it, because copper can oxidize, so I might want to spray it with something to protect it. So what's the surface area? How much paint have I got to buy if I'm going to make loads of these things? So I also want to determine the surface area. Have a look at the problem. How might we set about finding the mass of the hemispherical copper container? I'll start us off by doing what I always suggest you do, and that's draw it. Let's make a better effort than that. Maybe slightly better. So there's the copper container. That sort of shaped container is actually called a crucible. That's supposed to be a hemisphere, although it looks a bit elongated. So we've got this surface here, and then you've got the inside of this hemisphere, the crucible part of it. And we've got to determine the mass. If I were to just draw the top, then we can see that we've got some information. We've got the external radius is 12 centimeters, and the internal radius is 10. We've got to find the mass, assuming that 1 cubic centimetre of copper weighs 8.9 grams. So that's a key piece of information. So what can we do to try and find the mass? What formula is going to be useful to start off with? So we can already see that planning it involves finding the right formula, okay? Mass equals density times volume. And in fact, we've been given the density of this material because 8.9 grams of it weighs as a massive volume of 1 cubic centimetre. So this actually is the density. The density is 8.9 grams per cubic centimetre. So they might well have said to us the density is 8.9 grams per cubic centimetre, but they haven't. And if you think about it, that's obvious. Look, if this formula is obvious. I want to know the mass of this thing. The density is telling me that 1 cubic centimetre of it weighs 8.9 grams, or has a mass of 8.9 grams. So if I multiply that density by the volume, I'll get the mass of the whole thing, won't I? That makes sense? So what do I need? The plan to find the mass, I've got to find the volume, okay? Mass equals density times volume, so find the volume of the crucible. Let's call that VT for the total volume. How am I going to find that volume? Yep. Yep. That's exactly right, yes. Find the volume of the whole thing as though there was no hole in it, and then subtract the volume of the hole. So in other words, the total volume equals the volume of the, let's call that volume E for the external radius of the thing, minus VI for the internal radius of it. So now we need the formula. What's the formula? We've got here basically a hemisphere. So let's look at our formulae that we've got. You might remember it, but because we've just been looking at it, look, the volume of a sphere is 4/3 pi r cubed. So what's the volume of a hemisphere? Which would be 2/3 pi r cubed. So the formula for the volume of a hemisphere is 2/3 pi r cubed. So going back to our problem, the volume of a hemisphere, let's use an abbreviation HS for hemisphere, is 2/3 pi r cubed. So now we can use that formula to find the external volume and subtract the internal volume. We've got the volume of the crucible. Once we've got the volume of the crucible, we then multiply that by the density, which is 8.9, and we've got the mass. Problem done. Okay? So the first stage is to plan it. Mass is density times volume. So find the volume. The volume is the external volume minus the internal volume, and then we've found the formula that's going to help us, and we can work it out. Okay? So would you like to do that? One way to do this, you've calculated it and hopefully got the right answer, but this is another way you might have gone about doing it. Well, maybe this is the way you set it actually, but at this point I've got the formula for the volume of a hemisphere, and I know I'm going to take the external volume away from the internal volume, so actually the total volume, VT, is going to be 2/3 pi times the external radius cubed minus 2/3 pi times the internal radius cubed. If I left it as a formula, that's what I'm doing, isn't it? Well, we've looked at stuff like this before. If you look at the right-hand side, this expression can be factorised. We can take outside a bracket what's common to both of these. In other words, the total volume is 2/3 pi, because that's common to both, times the external radius cubed minus the internal radius cubed. So I could have done it that way and come up with the answer. Okay? I wanted to point that out as maybe a more mathematical way to do it. I know you're engineers, so however you do it, as long as you get the right answer, is fine, but I just wanted to point this out to you, okay, as another approach to keep it in terms of formulae, and then come up with a formula to find the volume of this crucible, if you like. The beauty of this method is that now I can find quickly the volume of any crucible given the external and internal radii. I just plug those numbers in. So I've got a general formula now to find the volume of a crucible. So you end up and you get the answer, hopefully, and then you times that by the density and you get 13.57 kilograms. What I wanted to show on this was, though, the plan. When it comes to your assignment, I want some sort of plan of action. I need to know what you're going to do. So when you do this, it's in the form of a report. You've got a shape that you're going to find the surface area and volume of. So you draw it. You put on the measurements. You write down what you're going to do, the plan of action to find the surface area and the volume of this shape, and then you calculate it and give the answer to an appropriate accuracy at the end. Yes. So now let's find the surface area of this crucible. Plan of action. I want to know all the area, the external exposed area of this crucible. So one plan would be to find the surface area of the outer hemisphere, surface area of the inner hemisphere, and the surface area of this disc connecting them. this bit here. Anybody come up with anything different? So now we've written down our plan, and that's a good plan, Matthew, okay? So we would go about doing it. And what I would suggest that you've drawn it, you've written your plan, and then you go through it. So in sections, surface area of outer hemisphere, as a title almost. And then do that calculation. What's the formula for the surface area of a hemisphere? If we go back to our, there's the surface area of a sphere, 4 pi r squared. So what's the surface area of a hemisphere? 2 pi r squared. So surface area equals 2 pi r squared. We can substitute in our value for r for the outer hemisphere and work out the surface area. And similar for the surface area of the inner hemisphere. What about the surface area for the disk? Here it is. How to find the surface area of that? Yeah, that's right. Find the surface area of the outer circle and subtract the surface area of the inner circle. So in other words, we have to do another little plan, you know. This equals surface area of outer circle using subscripts minus the surface area of the inner circle. And work it out. Yeah, Jack? It's Jack, isn't it? Okay, so carry it through the plan, please. Find the total surface area of that crucible. Okay, so surface area of the outer hemisphere is 2 pi times 12 squared gives 904 point. Okay. Because you rounded it up, did you? Anybody else work it out? What did you get? 905. Unit. Right, okay. Surface area of the inner hemisphere is square centimeters. And the surface area of the disk is square centimeters. So therefore you add them all together. So have another look at that then, George. So that you add them all together, 905 plus 628 plus 138, and you get the total surface area. Can you work that out? Okay. So again, more important at this point is not the answer, but the method. So if we look again at what we've done here, we've drawn it. With Matthew's help, we came up with a plan of action. So he did his bit there. And then he gave over the work to his technicians to actually do the boring calculation bit, which is to find the surface area of the outer hemisphere, the surface area of the inner hemisphere, the surface area of the disk. Note how it's been set out, please, so that it makes sense. And then the answer at the end. And that's the sort of thing I'm going to be asking in. I'm not expecting to copy this method, but something similar. Of course you can. If you want to do it that way, that's absolutely perfect, okay? I mean, that's why I've done it, because that's probably the way I would do it. So it's as good a method as any, okay? So long as it's clear. as long as your handwriting is clear. If your handwriting is not good, type it on Word, okay? And if you can't use the equation editor in Word, then leave spaces and put the calculations in afterwards, okay? But I don't mind it handwritten so long as it's neat. And there's your answer at the end, okay? Have a look now at that exercise, which I got this question from, which I think is on page 163, at some of the questions in there. So it's exercise 79, around the page 163.